Hello. In this video, we will discuss the various informed search techniques. The informed search techniques is a search technique where the goal state or the goal node is well known. Now, two major searching techniques under the informed search mechanism are greedy best first search and A-star search. Those are broadly, those are categorized as best first search. Now, what is best first search? Standing at the current node, the next node will be chosen, which is the best. Now, best in terms of what? Best in terms of some value. What kind of value it is? For which, let us discuss three functions. One is Fn, the value of the function. Typically, that represents the distance from the starting node to the goal node. The overall, the distance up to the goal node till, till the goal node comes. What is the overall cost? The function represents a cost. The cost means the amount of computational effort or the amount of computational time or the amount of space requirement. Those are categorized as cost. So Fn is the overall computing cost for reaching the goal. There's a Gn. Gn represents the cost of reaching the current position from the starting node. From the starting position to current position, what is the time or cost incurred? That is Gn. And another function is Hn. That's a heuristic function. Hn means the distance from the current node to the goal node, the remaining distance from the current node to the goal node. All functions are, all cost functions are, or we can say evaluation functions are like Fn, Gn, and Hn are the functions of n. N means the number of vertices, the number of nodes, or number of states. Now, the best first search broadly searches the best node, either best Fn or best Hn. So, whenever we are assuming the best neighbor, the best next node in terms of its distance from the goal, then the best node refers to that particular node which is closest to the goal. This means Hn is the only thing, only function, only cost function that is to be considered. That happens in case of greedy best first search. It's a greedy method, basically. It never gets satisfied till the goal reached. Now, in this greedy best first search, we'll consider the Hn factor, the Hn cost factor before choosing a neighbor. Whichever neighbor is closest to the goal, whichever neighbor offers least cost in reaching to the goal from that node is considered to be the next node. That is a greedy best first search. Now, as an example, we'd have a map of Romania as an example. Now, our destination is, goal is Bucharest. Our goal is Bucharest in this case. Now what we are doing, there is a schedule in the right-hand side of this particular figure. There is a schedule of the distances from Bucharest. Bucharest is a goal, we have assumed. We have to reach Bucharest at the end of the day. At the end of the search process, we have to reach Bucharest. So there are the schedules, distance schedules are mapped here, like Arad, 366 kilometers away from Bucharest, and Croatia, 160 kilometers away from Bucharest. There are other things like Lassi, 226 kilometers away from Bucharest. Zerinth, it is 374 kilometers away from Bucharest. So the distance variables are listed in terms of the distance from Bucharest. So values in terms of the distance from the goal, that is Bucharest. Those are the HN values. Those are called heuristic values. Straight line distance from Bucharest are mapped. Those are the heuristic values representing the straight line distance from the Bucharest. So here are some nodes in the graph. In the graphical view, we can see the vertices and the nodes. By vertices or nodes and the edges, that is Oradia, Zerin, Arad, etc. vertices are there. And in between there are the edges. The edges represent the distance between them, the cost or the distance between them. There's a distance from Arad to Zerin, that is 75, Zerin to Oradia 71, and so on. And they are having the heuristic values listed in the right hand side. Now let's start with the best first search with an example. Before that, what is greedy best first search? Greedy best first search, as I already told, considers only the HN values, that is the remaining distance from the current node, whichever the current node is, from the remaining distance from the current node to the goal node. That is the heuristic distance. Fn is a considerable overall cost that is to be considered before choosing a neighbor. And here, Fn is nothing but Hn itself. Fn, the overall cost function, is nothing but the heuristic cost function itself. In this case of greedy best first search, the n is the current node from nth node to the goal node, the distance of the cost. Okay. Now, the schedules are having the straight line distance from N to Bucharest. H SLD N. Straight SLD means straight line distance from N. That is the heuristic function. Heuristic values. Those represents the heuristic values, which is listed in the right side of the previous pages, this figure. Now, greedy best first search expands the node that appears to be closest to goal. It will choose the average step. The next node will be chosen, which is closest to the goal at that particular point of time. For example, it is expanding the example we are having, starting with Arad. If the Arad is the source, let us assume that Arad is a source node, and we are having the Arad. We can locate the Arad in the map here in this particular graph. Now, Arad, the heuristic value is 366, means the linear distance of Arad from Bucharest is 366 kilometers away. So now, Arad 366 is leveled by 366. After that, there are three alternate paths we have from Arad. There are three connected nodes the Arad is having: Sibiu, Timisoara, and Zerin. Sibiu, Timisoara, and Zerin. These three connected nodes the Arad is having. Just look at here. The Arad is having Sibiu, Timisoara, and Zerin. These three vertices are directly connected with Arad. Those three are the neighboring vertices. Those three are the connected vertices of Arad, the neighbors of Arad. So we are having these three neighbors. We explored the three neighbors of Arad. And CBU is having the heuristic value of 253 as per the schedule CBU. You can find the CBU. The schedule is as per the schedule. The heuristic value of CBU means the distance from Bucharest is 253. And similarly, all the other nodes like Timisoara, Zedin, all are having the heuristic values of 329 and 374, respectively. And then, what is the lowest among them? We will choose the lowest, is the closest to the Bucharest. Whichever vertex is closest to the Bucharest, we will choose that. So the CBU is the closest. It is having the least distance as compared to the other two. That is 253 is the lowest. Now we'll expand that. Now expanding CBU, what are the alternate paths are available from CBU? We can map the Arad, again the Arad, then Pegasus, Oradia, Rivnivisia. So those are the four places directly connected with CBU. So Arad is having again 366 because if we go to Arad, it is 366 kilometers away from Romania, from Bucharest. Pegasus 176, 380 is the Oradia, and Rivnivisia is 193. So among these four, the lowest is Pegasus. So let's expand that. We expanding Pegasus, we are having two adjacent nodes of Pegasus. CBU, which is closer to Bucharest, 253 kilometers away from Bucharest, which is 253 kilometers away from Bucharest, and Bucharest itself is obviously 0 kilometers away from Bucharest itself. So we have already arrived to the goal. So we are having the remaining value 0. So the process of greedy best first search will choose, will expand the neighbors and will choose the one of the expanded neighbors which is the closest to the goal, which is having the lowest HN value, which is having the lowest HN value. HN value means the distance from goal, that is Bucharest in this case. Until the HN value becomes 0, the process will go on. This is a greedy best first search. Now the problem is that, is it complete? No. It can stuck in loops. This can be stuck in looped. Why? Uradia as goal. Suppose, for example, if Uradia as goal, we can be, suppose, as Uradia as goal, Lassi Nimt, we will be oscillate between Lassi and Nimt infinitely. Just see the figure, it can be clear. From Lassi, if you are in Lassi, the heuristic function of Lassi is 226. Standing on Lassi, we have the Uradia, we have the Nimt, we have the heuristic value of Nimt as 234, 234. And for Lassi, we're 226. So definitely 226 and 234 from Bucharest. If Oradea is the goal, so Oradea is how much different, how much distant from Bucharest? We can see the Oradea in the map. It is 380 kilometers away from Bucharest. Okay. So it is 380 kilometers away from Bucharest. So definitely from Lassi, Nimt is closer than to Oradea. If I say, if I see the graph also by the optical intuition, we can easily see Oradea is linearly closer to Nimt. So while standing in Lassi, one person will jump to Nimt because Nimt is the closest. At this point of time, among all the neighbors, the Lassi is having two neighbors. One is Vasuli and another is Nimt. One is Vasui, another is Nimt. Among these two neighbors, the Nimt is closer to Uradia. So definitely Lassi will be, from Lassi, the agent will jump to Nimt. And from Nimt, and Nimt is having the, again from Nimt, there is no path available to Uradia. Even if the linear distance is lowest from Nimt to Uradia, among these two neighbors, but Nimt is not having any direct path to Uradia. So from again the agent will come from Nimt to Lassi. Again from Lassi to Nimt, because Nimt is closest to Uradia. Again Nimt, there is no other path, no other option other than coming to Lassi. So the agent will again come back to Lassi. So infinite number of times, infinitely, the agent will oscillate between Nimt and Lassi. So it will never go out of that particular trap. It will be get trapped, get stuck into that place. It can stuck in loops. Lassi Nimt, infinitely it will go What is the time complexity? Time complexity b to the power m, where b is the branching factor and m is the depth of the search tree up to which the search is made, up to which the goal is found. So that is b to the power n is the time complexity. Let's see here, the branching factor is typically, the branching factor is 3. So we are having the branching factor 3. So at this stage, 3 and the level is 1. Okay. So the level is 1. Time complexity is 3 only. So now, if the branching factor is 4, the level we have achieved at 0, 1, 2. So level is 4. The branching factor is 4 because we are having 4 descendants, 4 connected neighbors of CBU. So branching factor is 4. And we are having the level 0, 1, 2 level. Third level actually, if the counting starts from 1. The level 3, we are having the branching factor 4. So the time complexity is the branching factor to the power level. Branching factor to the power level. So that is the time complexity of chopping out. Similarly, we have the space requirement is also b to the power m. That is branching factor to the power m means the level. Because all the nodes has to be stored in the memory. All the nodes has to be stored in the memory. Otherwise, the nodes cannot be used to find out, to examine their heuristic values and to compare. So optimal, no, it is not optimal. It is suboptimal. Why? It is suboptimal. It is not complete. Number one, it can stuck into the loops like we have seen, Lassi nim, because linear distance is shown. And linear distance, if there is no direct path, so there is a loop where it can be stuck. The time complexity is too high, b to the power n. Space complexity is also b to the power n, where b is the branching factor and m is the level. Now, optimal, it is not optimal, it is suboptimal because it is only considering the remaining value. It is only considering the remaining cost function from current node to the goal node. Then what about the cost already beared, already incurred in reaching to the current node from the source node? From the source node to current node, some cost is already incurred. That cost is never considered in this greedy-based first search. So that's why it is suboptimal. So it can be much more better. Now the A-star search. A-star search tells that not only the HN values are considered, should be considered, but also GN values should also be considered. So for A-star search, Fn is equal to, Fn means that before considering, overall cost before considering a neighbor, Fn is a sum of Gn plus Hn. Means already incurred cost in coming to the current node plus the cost to be incurred from current node to goal node. So overall cost is a sum of the cost which is already incurred plus the cost it's going to be incurred to the goal node. The distance which is already covered plus the distance yet to be covered from the next node. What is the cost we have to bear to come to the next node, that is GN? Next node will eventually become the current node or not. To judge that, we have to find out the GN, means what is the cost we have to bear for reaching to the current next node before selecting it as current node. What is the cost we have to bear from the starting node to the next node, plus the cost that we have to bear the next node to the goal node. The total overall cost function Fn is the sum of Gn plus Hn. Okay. So now this is the overall estimation, and this may lead to the optimal solution because it will consider the overall costs. Now let's have the example. Arad. Arad is a source node. That definitely the Arad's value, Fn value will be Gn plus Hn because Arad is a source. Definitely from Arad, the distance of Arad is 0. From Arad, Arad is a source and Bucharest is a destination. Bucharest is a goal node, and Arad is a source node. So definitely the Arad's HFN value equal to Gn plus Hn. Gn means from source to the current node. Source node is the Arad and current node is also Arad. So definitely Gn is 0. And Hn we are having 366, the linear distance from Arad to Bucharest. So total Fn is 366. We are having three descendants, Sibiu, Timisoara, and Zerin. For Sibiu, we are having the Fn equal to 140, that is Gn. That is a cost to be incurred in reaching Sibiu, the total distance of Sibiu from Arad plus the Hn value of Sibiu means the distance from Sibiu to Bucharest, that is 253. So total Fn cost is 393. We are having 393. So this is a cost we have to bear if we select CBU, the total cost of selecting CBU, that is 290, 393. Divisoria 447, Zerin 449. So why 140? From Arad to CBU, you can find the map. Comfortably, you can find the map. From Arad to CBU, there's a distance that age is level by 140. The distance from Arad to CBU is 140. So that will also be considered. So 140. Likewise, from Arad to Timisoara, that is 118. And from Timisoara to Bucharest, 329. So Gn plus Hn equal to Fn. Fn equal to 447. So Fn value is considered. The overall Fn value as a sum of Gn plus Hn, that is considered. So the lowest among these is 393. Then CB is expanded. We are having four nodes again, four neighbors. Arad, Pegasus, Oradia, Timisoara. So Brahminivisya, sorry. So these four nodes we are having. The from Arad to CBU, CBU to Arad. So that cost is 280 because from Arad to CBU, cost is 140. Again, from CBU to back Arad, we have to bear another 140 cost. The distance from Arad to CBU is 140. If we travel from Arad to CBU and CBU to Arad back, so it is 140 plus 140, 280 will be the GN value plus 366 of Arad, that is 646. Total FN value. Similarly, all the variables are having the FN values calculated. The the Rimnivicia is providing with the lowest FN value among all these four. Now we'll expand. Let's expand it. Expanding the Rimnivicia, we are having three neighbors. The FN values are calculated just likewise. The GN values of Croatia is 366. From Arad through CBU and Rimnivicia, it takes 366 kilometers to reach Croatia. So GN value of Croatia is 366 and 160 is the HN value of Croatia. So total it is a FN value of Croatia 526. Similarly, Vitesti is having the total FN value is 417 and CDU is having the total FN value is 553. Now the thing is that among these FN values, whatever we can see, we are having even lesser FN value of, we can find a lesser FN value in one of the sibling nodes of Remnivisia itself. So that is Pegasus. So Pegasus is having even lower FN value than all these three. So let's expand Pegasus. After expanding Pegasus, we found Bucharest, which is incurring 450. 450 is the total FN cost in coming to Bucharest through this path. Arad, Sibiu, Pegasus, Bucharest. 450 is the total FN value. Now, 450, we can find even lower than 450 in the Pitesti now. Now we compare all the nodes which is already expanded and calculated with the current. That is the redness of Esther search. that the current node's Fn value is compared with not only its descendant neighbors, but also already expanded neighbors, already visited nodes, I'm sorry, not only its descendant neighbors, but also already visited nodes, already calculated nodes. So that is among these, we can find Pitesti is having the lower cost function value, lower Fn value than Bucharest. Then Bucharest, directly coming from Pegasus to Bucharest. If from Sibiu to Dimnivicia to Pitesti, if we come, then the Fn value is lower, 417. Pitesti is having. Let's expand Pitesti now. If I expand Pitesti, then Pitesti to Bucharest, we are having Pitesti to Bucharest, we are having 418. So it is 418. How it comes? This is 417 from Pitesti to Bucharest. It is adding only one, that is 418. Again, you see from Pitesti to Bucharest. See here the schedule of Pitesti. 10 itself. 10. 10 is the distance from Bucharest to Pitesti. So if I choose Pitesti, it is having the Fn value of 417, which is lower than choosing the Bucharest from Pegasus. So we'll change the path. We'll have the backtracking. We'll go to Sibiu. By backtracking, we'll go to Sibiu. Then again Rindivesya. Then Pitesti. We'll choose Pitesti. Choose to expand Pitesti. So 417. So we are having Pitesti. The total Fn value is 417. And after that, we are having the Bucharest. We are having the Bucharest is 417 plus 10. That is 427. That is printing mistake. 427, the Bucharest is, which is much lower than the other alternatives of Croatia and Revnevicia. And Bucharest is reached with 418, which is lower than the previous goal estimation of 450 if we could arrive Bucharest through Pegasus. So we'll choose this path. Now this path is optimal. Why? Arad to Sibiu, Sibiu to Rivnivicia to Pitesti, Pitesti to Bucharest. That path will offer the lowest overall cost, not only the lowest remaining cost, not only the lowest FN value, HN value, I'm sorry, but the overall FN value is minimized if I choose this path. This is the Esther algorithm. Firstly, it assumes it considers not only the HN values, remaining cost, but also it considers the overall cost as a sum of already incurred cost GN plus remaining cost HN. Secondly, at every point, at each point, at each state, or at each level, the total Fn value of a certain node is compared with all the already explored and visited nodes Fn values. Whichever already visited or already explored nodes, Fn value is found to be lower than the current, then the process will expand that lower one, the lower node. That is the betterment of A star. And this is optimal. This is not suboptimal. This is optimal and complete. And it guarantees for shortest path. Because the HN, for every node n, HN is less than the minimum permissible HN. H star n is the true cost to reach the goal state from n. Is a true cost, is a linear cost. So our HN will be less than equal to the true cost. Either equal to or less than equal to. The maximum HN of A star search will be the maximum remaining cost of A star algorithm will be H star n. H star n is the true cost. So either equal to the true cost or even less than the true cost it provides with. Now, the tree is optimal. So, thank you so much. So these are the two inform such algorithms discussed in this video. And next video, we'll discuss the other advanced techniques as well. Thank you so much.